Good morning. Thank you for joining us. My name is Lisa Shaw, and I work on the marketing team at SICK. SICK is a leading provider of sensor solutions. Today, Chris Scott, a market product manager for industrial safety products at SICK, will be talking about the fast solution for speed and separation monitoring in a collaborative robot application. He will also be sharing how to quickly implement speed and separation monitoring, how to program a safety scanner to be achieved without the use of a separate PC or software, and so much more. A little more information about Chris is he has been with SICK for over 6 years in various roles. For the last 3 years, Chris has focused on the development and implementation of safety systems, specifically in robot applications. Just a little housekeeping before we get started. If you have any questions during today's presentation, please type them into the Q&A box in your control panel, which can be found on the right-hand side of your screen. We'll take some time at the end of today's session to address as many questions as time allows. Also, a recording of this webinar will be emailed to you following today's presentation. Now, without further ado, let's turn our time over to Chris. Chris, please take it away.
All right, thank you, Lisa. I appreciate it. Again, my name is Chris Scott. I'm a market product manager in the industrial safety group here at SICK, and we're here today to talk about a new fast solution for speed and separation monitoring in robot applications. In terms of an agenda today, pretty short and sweet. I want to touch a little bit about human-robot collaboration and kind of help bring around some definitions and some common understanding. I do want to talk about some of the customer challenges I've seen over the last 3 years working in robot safety and introduce you to, again, our new solution. So in terms of human and robot collaboration, we're really focusing on two ideas, two concepts. We're considering space and time, a workspace and the time spent working on a process. And if you consider an application where humans are working in the same space as a robot, but they're interacting with the material at different times, to me that would be a cooperative type application. And when we have humans working side by side with robots, working on the same materials at the same time in the same space, to me that's a collaborative application. And another type of application would be a coexisting application. And really an application like this would be, we have a robot working on one side of the fence doing its thing and humans working on the other side of the fence, and there's real no need for interaction in the same space. So that would be like a coexistence application. Again, these collaborative applications are where, people are working side by side with robots. And here's a great example of a human, using a robot to do some hand guiding and helping to install some, product or parts into an automobile, right? This would be a collaborative type application. And then cooperative type applications. This is, again, in a process like this, maybe humans are bringing in raw materials, the robot's working on a process and creating a finished good, and then, humans would also take that finished good out of the workspace. We're working side by side, but not on the same thing at the same time. So this is more of a cooperative type application. And this is really the types of applications that our safe robotics area protection systems are really geared towards, right? They're really meant and bring value to applications where, we're intermittently interacting with the robot. So when it comes to human-robot collaboration, there's essentially 4 different types of collaborative operations that are defined in the standards. The RIA Technical Report 15606 for collaborative robots describes 4, right? We have something called a monitored safe stop or a protective stop. This is where as you approach a robot, it's going to stop and not move until you leave the area. We have something like manual control, again, very similar to that automotive application where, a human is using the robot to assist them in a task, right? And then it's all under manual control. We do have something called power and force limiting, and this is kind of that traditional, what everybody thinks of as, a collaborative robot or a cobot, right? Where the safety is when the robot touches you or touches the human, it stops moving, right? And that's the safety behind it. And then the last type of collaborative operation would be what we call speed and separation monitoring. And this is where we can have a robot moving at full production speed, and then as a person approaches that robot, we can slow the robot down to reduce the size of the safety distance required for the application, right? Allow people to get closer without the robot actually having to stop. So when it comes to the applications that our protection systems really focus on, the operations that we work with are that monitored safe stop or a protective stop function and the speed and separation monitoring. So some of the customer challenges out there, these are the three big themes that I've seen over the last 3 years. First, there are a few misconceptions out there. I've heard this phrase so many times, right? My cobot is inherently safe, right? It's a collaborative robot. I don't need safety, right? Safety is built in. That's true, but to some extent, and I'll dive into that in a minute. The other challenges customers are facing are productivity challenges, right? We've installed a robot and it's not working the way we wanted it to. It's not as productive as I thought it was going to be. And then things like commissioning effort, right? Somebody's taken the time to install and develop the robot application. Then then they start addressing safety, and it just becomes too complicated, and customers get frustrated. So first things first. I don't need safety, right? It's a collaborative robot. I'm going to go directly back to the standard RIA 1506, and within that standard in section 510. Describing power and force limiting or inherent by design control. This is, again, that collaborative, that cobot type safety system. The standard is very explicit. It says that component, power and force limiting, you need to understand that the robot is just a component of the final collaborative robot system. And power and force limiting on its own, on just the robot, is not sufficient for safe collaboration, right? We need to take the entire application into account. You need to consider the end effector. You need to consider the material being, interacted with, and so on. You need to look at the whole process in general, right? How people are interacting with that system, right? And you do that via a risk assessment, right? So at a very minimum, you should be doing a risk assessment to make sure that power and force limiting is appropriate. But the other thing I'll point out, and this kind of leads to that second item of productivity, is that power and force limiting by itself may be a great way to do and implement safety in your system, but it has a tendency to be very slow, right? For power and force limiting to work, it has to stop when it impacts a person. But there's another component there, and that's force, right? If that robot's moving fast and hits somebody with enough force, it may be beyond the expectation. It may injure somebody, even though we have power and force limiting in place. So for the last two customer challenges, in terms of productivity and commissioning effort, I'd like to dive right in and introduce you to our new safety systems, the SBOT Stop UR Cap and SBOT Speed UR Cap. In terms of addressing those other two main challenges of productivity and commissioning, right, this is kind of the highlights of these systems, right? Both of these systems are very fast and easy to set up, right? To implement, program the scanners, it's all done in a graphical interface right on the UR Robot Teach pendant, right? In terms of productivity, we have some great smart features that help you program those scanners, as well as allow the implementation of things like an automatic restart or the speed reduction of the robot instead of making it stop every time, right? All of these things will improve productivity. In terms of reduced commissioning efforts, it's very, very simple. You land 6 wires to the robot controller, you plug in an Ethernet connector, and you're off to the races, right? The other thing that we do is we include lots of documentation and detailed wiring diagrams and so on, to allow you to quickly and easily, commission this type of an application. These types of systems really allow us to
Looks like we lost our presenter's audio. We'll try to restart that. Thanks for your patience.
Am I back?
You are back, yes.
My apologies. I am having some wonderful technical challenges here these days. I think I knew where I dropped off, but I'll dive right back in here. So these robot systems really give us the opportunity to create and implement some free and safe access to robot applications, right? We're utilizing state-of-the-art laser scanner technology, the latest and greatest technology of laser scanners from SICK, the people who invented the safety laser scanner. We're utilizing some predefined safety functions, and this really allows us to achieve a very high safety performance level, right up to PLD. Right? And another great thing about these systems is they're very future-proof, very expandable, right? This is a very core system, right? We're talking about a laser scanner directly connected to a robot. It's also very easy to add a safety controller to this system and add a second or third laser scanner, or light curtains, or whatever you need to do. So this is kind of a starting point, but you can do much more and still not have wasted your time with a system starting here like this. So again, both of these systems, the S-Spot Stop UR Cap and the S-Spot Speed UR Cap, are really simple systems based on the combination of the NanoScan 3 safety laser scanner, the accessories needed to install it, right? A mounting bracket, the system plug, and the I/O cable. There's the configuration tool, right? This is the software that you drop onto the UR Teach pendant, and it allows you to program that safety laser scanner or scanners and utilize the robot safety features that exist within the UR robot controller. So when it comes to these two systems, when it comes to the predefined functions, right, when we're talking about the S-Spot Stop UR Cap, we're talking about being able to implement a protective stop, right, or that safe stop mode that we had talked about earlier, and we're also able to implement an automatic restart. And we do this with the specific NanoScan laser scanner, which is our NanoScan core, and that's the one that has a single protective field and a warning field. For the S-Spot Speed UR Cap, we're also, on top of the protective stop and automatic restart, we're also able to implement a reduced speed mode, and we do this with the NanoScan 3 Pro. The NanoScan 3 Pro allows us to have two safety-rated monitored fields at the same time. Now, the nice thing about this system is it's the same platform, right? It's the same software. The UR Cap tool that's programmed on the Teach pendant will recognize which scanner you have and allow you to program the functions that are associated with those scanners, right? And it's all done very simply and very easily on the right on the programming pendant. So those of you that are familiar with SICK safety laser scanners may have heard us talk about programs like FlexiSoft Designer or Safety Designer, and those are the the programs that we typically use to program our scanners or program our controllers. This program is a configuration tool for the safety laser scanner. You don't need to use Safety Designer or FlexiSoft Designer. The other nice thing about this tool, this UR Cap tool, is it's a single tool that you can use for both commissioning, diagnosis, verification, and generating your reports when you're all said and done. And all this then again gets tied together via some smart features that allow for the quick and easy configuration of those scanners. And I'll talk about those in a minute. But I do want to say that, again, this NanoScan 3 tool, it's not a complete replacement for Safety Designer, right? There's a lot of things that Safety Designer does that you just can't possibly get into the tool. So some of the more advanced diagnostics features and so on, you're not able to see on the UR pendant. You could, if you really needed them, you could still plug in and use Safety Designer with that NanoScan. But again, you don't have to do that to implement this entire system. So I mentioned that this UR Cap tool has a lot of smart features. It is a really slick and easy to use tool. One of the great things about it, it's got a really nice clear layout. We have this feature called Smart Field Definition, which allows us to program our reduced speed zone and our stop zones very quickly and easily. We have the ability to teach in those fields with literally the touch of a button with Field Set Teach In. The other great thing is we have simultaneous scan data. We can see the data from 2 laser scanners at the same time on the same screen. And when we program those safety laser scanners, the system will automatically fuse those protective fields together to create one continuous field set. For some quick and easy adjustments and manipulation, we have something called Smart Wall that allows us to mask areas that we don't want to be visible by the safety system for one reason or another. And then there's a really nice configuration, commissioning feature that walks you through and makes you answer some questions to make sure that you've created a safe and viable system. So when it comes to these smart features, I do want to dive in and kind of explain what they really are. First and foremost is a clear layout. This is an actual image from a UR pendant that you would see while using this tool. What you see is a robot sitting on a table or a pedestal of some kind. The robot's labeled R. We have 2 laser scanners in the picture here, both A and B. And you see little top hats on top of those scanners, and that's the orientation of the scanner. You know, which way is it pointing? So when you're in the tool and setting up your system, you define the location of the robot on your table, you define the size of your table, you can drag and drop the location of your scanners wherever you have them and orient them in space so they're pointing in the direction that they are in life. When it comes to smart field definition, there's a couple of different modes and ways to do this. One we call robot-centric and one we call free fields. But really what this is it's the ability to, program in and determine what that distance needs to be for the size of those fields. And when you go to teach them, then it's going to teach the field to that specific size, right? You've calculated a safety distance, you plug in that distance required in, and that's the field that you're going to program when you teach it. In terms of robot-centric, what we do is we determine that, that safety distance is generated from the center of the robot, right? So it's very easy and quick to define where those fields are going to be. Okay. In terms of free fields, what you're able to do is not only, consider the area and space needed for the robot safety, but also from some other things around the area, right? If you look at the picture down in the lower right, you can see an application where, the safety laser scanner, we're trying to protect an area more than just right in front of the robot, or, we're concerned about the conveyor and so on. So we can expand that with the NanoScan 3 tool. Another great feature with the UR cap tool is this idea to be able to teach in a safety laser scanner, teach in both fields, right? We're teaching in both that stop field and that reduced mode field with literally the touch of a button, right? You press teach area, there's a small delay that you can program in. So if you're standing next to the robot, you have time to leave the area so that you're not interfering with the teaching of that safety laser scanner. And it will teach those 2 fields and program them in right into the scanner. I think one of the neatest features, though, with this is this simultaneous scan data. And what this does is allows us to visualize 2 laser scanners in an application. So A and B on the screen are 2 laser scanners. And you can see the blue lines and the green lines kind of around the area, right? That's representing live scan data from those scanners. And you're able to visualize live scan data for 2 laser scanners at the same time on the same screen. This is something that we don't even do with our SICK software, but we do have this feature and function within the NanoScan 3 UR cap. And then to take it a step further, when we go to actually teach in this application, you can actually teach both scanners at the same time, right? You don't have to teach one and then the other. You don't have to do what you used to have to do, which is, you teach a scanner, then you line up the other one and you try to get the fields to line up and match. What this will do is it'll teach both scanners at the same time, and it will merge the scan fields from both scanners together to create these protective fields or warning fields. right? So if you look at the screen, you'll see that first inner radius, right? This is our stop zone, and you can see from scanner B and scanner A where they've merged, right? We've fused the fields here together to create this stop zone field, and down here in this reduced speed mode field, we've merged the fields again between A and B to create this one continuous field set. And then another really slick feature is the smart wall. And what this does is it allows us again to mask areas that we don't want the scanners to pay attention to. Say, for example, we have some type of a fence or a guard on the back side of this wall that we've drawn here. We don't care if somebody walks up to this wall and is officially close to that scanner because they're behind that fence, and we just don't want them to trip the scanner. So we can draw a wall here to mask what's behind that fence or that door. And then finally, the commissioning feature. This is pretty slick. When you're all done, we're going to walk you through step by step and ask you some questions about the application to ensure that it's safe and it meets your needs, right? We're going to make sure that any area that's not viewed by the scanner that nobody can get into, you're going to verify that. You're going to verify that the monitoring figure, the fields that you trigger are triggering correctly into the robot controller, right? So we're sending the correct signals to the robot. We're going to verify that, the only way to access that application or to get to the robot is to go through these fields, these protective fields that we've just created. And also verify that it's not possible to bypass the field, right? We don't want, the last thing you want to do is create an application where, we've protected a space, but then somebody can get around that and injure themselves. But once you're done with that and you verify all these things, you check the boxes, you press next, and you're off to the races. Your system is completely set up. So just to kind of, bring it all together, right? We're talking about a safety system that really taps into the safety of the UR robot itself, right? We're programming everything. We're programming the robot, and we're programming the safety laser scanner through that UR robot teach pendant, okay? We're implementing safety functions like automatic restart, and we're doing this without the use of a PC, right? We don't have to have a PC to do any of this. Really, really kind of revolutionary in my mind. So when it comes to applications, right? I mean, this, every application is unique. This system in particular is geared towards, handling applications, right? We want applications that are stationary, although, I mean, they could be mobile in the sense that you reset, in different locations. And with the UR cap tool, it'd be very easy to reteach that safety laser scanner, right? To recreate that, to do a new safety system. But ultimately, it's not. We're not looking at systems that are on, say, a mobile robot, right? We are, we're looking for a robot arm that's going to be mounted on a desk or a pillar of some kind, and we're looking for applications where we do want free and open access to that application, right, and still protect the area. So handling applications like machine tending, pick and place applications, and packaging, and so on are really pretty ideal for this type of a fast solution. When it comes to what you're looking for from SICK, what you get, right? We have the two systems. We have one part number for all of the hardware and the software that you need for the SBOT Stop UR cap and for the SBOT Speed UR cap. If you already have a NanoScan 3 laser scanner, we do sell the software separately, and we sell it two different ways. We can sell it with all of the documentation that guides you through the setup and provides you the wiring diagrams and so on, as well as a Systema file so that you can calculate your performance level after everything's said and done. Or if you've done 100 of these and you don't need all that, you just want the license to put a program on your pendant, we offer that as a standalone as well. And with that, that is the SBOT Speed and SBOT Stop UR cap systems. Are there any questions?
Thank you, Chris. That was great. Just as Chris mentioned, we'll go ahead and take some time for some questions. As a reminder, if you have any, you can type them into the Q&A box on the right-hand side of your screen. So Chris, the first question we have is, do you have a system like this for FANUC robots?
Not quite yet. We do definitely have safe robot SBOT systems for FANUC robots in particular. We do connect to that FANUC robot via SIP-Safe, which is very nice. But we do have, it's done with a robot, with one of our FlexiSoft safety controllers. And we don't have the ability to program through the FANUC pendant yet, hopefully soon.
Awesome. The next question is from Wes, and he asks, how do they determine what slow speed is slow enough?
So the UR robot has, and I'm not a complete expert for UR robots, but the UR robot has what's called a reduced speed mode. And it's really kind of a there's two ways to implement it in the UR controller. One is you use the default settings, right? So you set up your production speed and it calculates all the forces and turns and all that kind of stuff. And then it has a kind of a, 50% mode, so to speak, where it reduces the speed and forces by half or by 60%. And there is a kind of a default, and you can customize it as well, but it's something that you would choose in the setup of the UR robot. And the SIC system will then trigger that to execute, right? So you set up the reduced mode, desired speed that you have, and then the safety system will trigger that to turn on when somebody approaches that application.
Awesome. Is there an SDK kit that allows other manufacturers to develop this for their robots?
Not yet. We don't have it out there for the other manufacturers. I'm not quite sure if there's a specific safety reason or why behind there, but there are SDK kits out there for 6 safety laser scanners, but not ones that allow you to access the safety function, right? The NanoScan 3 tool is used a lot, or the NanoScan 3 safety laser scanner is used a lot in AGVs and AMRs and AGCs. And you can actually get very detailed navigation point cloud type data from the safety laser scanner. And we do provide SDK kits out there to access that information, just not the safety function information.
Great. Can this system work with any of 6 safety scanners or just the NanoScan?
Yeah, at this time, the system only works with the NanoScan 3 safety laser scanner. It doesn't work with the microscan.
Cool. Will FANUC be brand labeling your scanner or the scanner?
I have not heard anything like that.
Okay. The next question is, in the SBOT stop UR cap, what is the warning field used for?
Oh, it's a good question. So with the SBOT stop UR cap, right, the scanner that we use is the NanoScan 3 core, and that has one safety rated protective field, and then we can use a warning field. The warning field is it's a kind of a wild card in the sense you can choose what you use it for. The system will allow you to maybe turn a light on or have some type of an alarm giving people notice that they're approaching the application. But it's not going to affect any function of the robot, right? We're not going to slow the robot down or stop the robot in the warning field. We're just going to let you know that you're close. And then once you were to continue closer and actually infringe upon that protective field that's close to the robot, then the system just stops. And when you leave, then the automatic restart will take place. Yeah, the warning field is really, truly just a warning field in that system.
Great. Are there any plans to develop a similar system with other collaborative robot manufacturers?
Yes, my list has been submitted for for the systems that I want done, and just about every one of them. I think there's a lot of we've developed a lot of safety systems for a lot of different manufacturers, right? For Fanuc, for Kuka, for Yaskawa. We've done several systems for UR. This is definitely the first pendant type application that we've done. I've requested more pendant applications as well as more systems for other robots as well too. There's definitely some robots out there that we could use some very specific customized systems for.
Cool. I'm seeing some pricing questions and some very specific product questions, and I'll have Chris reach out to those who've asked those questions. But Chris, that's all the questions I'm seeing now. Is there anything you want to mention before we wrap it up?
No, definitely. I will, like Lisa said, I can reach out to anybody who's left a question that we haven't been able to answer here. Definitely specific pricing questions and so on, I'll address to you individually. If you like, feel free to reach out to me. My email address is very easy. It's chris.scott@sick.com. Very simple, very fast, and I'm happy to help you with anything I can.
Thanks again, Chris, and thanks to our attendees. All of our upcoming webinars or can be found on sick.com and our monthly newsletter. Thanks again, and have a great day, everyone.